Alright, I am back for the section 5.3 self-recording, so we're just going to go ahead and just get started. The first problem you have us do is number 23, and this is under the group of terms with common factors. It asks us to write an equivalent expression by factoring out the greatest common factor. So our problem is going to be 9x to the third power y6 z2 minus 12x to the fourth power y to the fourth power z to the fourth power plus 15x squared y to the fifth power and z cubed. So I've already kind of wrote this down already, and this is kind of what we got here so far. So just taking a look at the problem here, we need to find out our greatest common factor. Thankfully with this one it's pretty simple. If we take a look at our numbers first, we can tell they all are divided by or multiplied by the number 3. So that's going to be my numerical of the greatest common factor, because 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. So that kind of makes life a little bit easier there. So now we need to find out the greatest common factor for our variables. So with that being the case, we need to look for our smallest here. So we have x cubed, x to the fourth power, and x squared. X squared is going to be our greatest common factor. With y, we've got y to the sixth, y to the fourth, and y to the fifth. So y fourth is our answer. And then z, we have z squared, z to the fourth, and z cubed. So z squared is going to be our greatest common factor. So then we're going to rewrite this as 3x squared y to the fourth and z squared times. So then now taking a look at our top part of the problem here. So what is 3 to 9? What does that multiply? So that's pretty simple. So it's going to be 3. But now we take our exponents here, and we need to subtract them. This is the easiest way I have done it, is to subtract from the top of our problem, which technically you could do addition, but I find it easier to do subtraction. So I have x squared here, and this is x to the third. I just need to write x. For my y variable and its exponent, I have y6. My original is y to the fourth, so I'm going to put y to the second. And since we already have a z squared and our greatest our factored out part down here, we don't need to add that. So we're then just going to move on to the next part. So I kind of also like to do this as well, put these in parentheses so I don't mess up. So now what goes into 12 from 3? So 3 times 4. So we're going to put 4. Same thing, x2 minus x4. That's going to give me x squared that I need to put. And then for our y value, same thing as before with the z value, our y variable with its exponent, it has 4, so we don't need to add that, because when we times this whole 3x squared y4 z squared into 4x squared, it's going to already add that y to the fourth. So then looking at our z exponent, here we have 4, so we do need to add z to the second power. Last but not least, same thing. So what does 3 go into 15? That's 5. So x squared is already part of it, so we don't need to add that since that's going to be added here with our factored out problem. So y fifth, or y's exponent is 5, and the original exponent down here is 4, so I just need to add y. And z cubed, we just need to have one more z to it, since z squared is already in our original problem, so that's going to be a z. And this is our factored out solution. So 3x squared y4 z squared times 3xy squared minus 4x squared z squared plus 5yz. And that is going to give us our top part there, and that's all I got for 23. Pretty simple and straightforward. Alright, so for our next problem is number 30. It asks us to write an equivalent expression by factoring out a factor with a negative coefficient. So our problem is negative 2x squared plus 4x minus 12 That's what we got here. So kind of just taking a look at it here, we can tell -2 is our greatest common factor, as it is, of course, our lowest coefficient, and then it does go into 4x and 12 as well. So then now we basically going to do kind of the same thing that we did the last time, but this time it's a little bit trickier. We don't have an exponent where 12 is, or we don't have a variable with it. So we're going to first start off with -2. That is going to be our first step here, times. So with here we have x squared, so we don't need to add x squared to the first part, because if we do, then as I mentioned before, that's going to add it to 12, and we can't have that. So I'm just going to have -2 times x squared. That will give us -2x squared. Now, since we have a positive 4x, we need to times a negative to a negative, so that's going to be -2x. So a -2 times -2x, that will give us a positive 4x. And then now, since we need to have a negative number for number 12 here, our last part is going to be +6. Because when we have -2 times a positive 6, that's going to give us a -12. And this is the answer. -2 times x squared minus 2x plus 6 will give us -2x squared plus 4x minus 12. And that is it. The expression by factoring out a negative coefficient. Alright, so for the next problem is number 40, and you have us write an equivalent expression by factoring. So our problem goes r times t minus 3 minus 6, s times t minus 3. So just writing it out here, right here, this kind of gives us most of the problem right away. It makes it pretty simple. Our quantity value is t minus 3, and that's already in the parentheses for both parts of this equation. So, like I said, that makes life a lot easy. So our first part of this is going to be t minus 3, and then we need to add the r and the s times r minus s. Oh, that's a 6. Oh, I need to apparently drink some more coffee here. So then that's going to be our answer, is parenthesis t minus 3 times, in parenthesis r minus s, as in Sam. So, like I said, with our quantity and our expression here in the parentheses being the same, we don't have to factor anything else, and pretty simple and straightforward. Alright, so for the last problem, we're still going to be factoring by grouping. And so our problem is number 50, and that is a cubed minus 3a squared plus 6 minus 2a. So I've kind of got that wrote out already here. So kind of following the directions of what you showed us in the notes, we need to add our negative numbers to make this a little bit easier. So I'm going to rewrite this, because we originally wow, let's try that again. Our intention is to kind of split this apart so that we can get the same quantity, kind of like in our last problem here, except for a minus or a plus something. So first off, our first part is going to be written as a3 plus a negative 3a squared, enter parenthesis, plus 6 plus negative 2a. So for our first part here with the a cubed plus negative 3a squared, we kind of need to take a look at it and see, okay, well, what can be factored out? What is going to be the same throughout this entire equation here to kind of start us out with? So with what we can tell here is we have a to the third power and a to the second power. We can definitely take a squared out of both. So that's what we're going to put down for our first part. It's going to be a squared times. And we're going to put a because we have a leftover a. We can't just get rid of it. It's still part of the equation. So we're going to put a, and then in order to get a negative, we need to times by a negative. So we're left with a negative 3. So a minus 3. So then just to kind of double check our work here, we can always use the distributive factor and times this back in. So it'd be a squared. That's not a2, sorry. Let's try that again. A squared. There we go. So a squared times a would give us a to the third power, and then a squared times negative 3 would give us negative 3a squared. So kind of works out there. So then going over here to the second part of the problem, we don't have the same variables, so we can't kind of use the same method as beforehand, so we need to think of this a little bit different. So I'm going to kind of ignore the a variable there. So between 6 and -2, what's something that's common between both of those? Obviously, it's going to be -2 because that's our smallest number that we have. That would work for both, because 3 times 2 is going to be 6, and then -2 times 1, or 2 times 1, that's pretty, simple. 2 is the lowest number, we can go next to 1. So we're going to put 2 as our first part to our problem here, so it's going to be 2 times. So then now we need to kind of take a look at here of of what could be times into 6 and then -2a. So kind of going with originally from here, if you kind of just go by the way it's written out here, 2 times 3 is 6, so it'd be 3, and then -a, because 2 times -a would be -2a. And so technically, okay, so this is kind of where things are a little backwards. I'm not certain if I exactly got this right. I'm going to show the next step of what I did to get the right answer, but a minus 3, that seems to be the answer to our factoring here. So technically with this second part, I have it wrote out in my original worksheet over here as 2a minus 3, because technically we kind of, it needs to be the same. Now, I could be wrong. I don't know if it doesn't necessarily matter, as long as I have the quantity of at least the same variable and the same number, and either positive or negative. Not entirely certain, but that's kind of where I got to, so I'm just going to kind of go with that. And well, that's what I've got for this, so I will see you for the next recording.